So in this case, the first picture right there, without the little flags looking things, is the first thing we would know. Okay? We'll call this angle ABC. And we'll call this point O, just for change of scenery. Okay? Now, does it say that point O is equidistant to point A and point C? No. We don't even know if AB is the same length as BC. What it does say, however, is that point O is the same distance to the segments. Now we've got to find the points or the distances that are the same. So let me ask you a question. If I brought a tape measure in here and asked Meredith, to measure how far your desk is from this wall, when you put your tape measure right there at the desk, where would you go to measure?
To the wall.
Where on the wall, though?
Point right across from me.
Right across from you, right? Perpendicular to the wall. Why wouldn't you measure, like, say, from your desk to over here?
That's not where I am.
Because that just, I don't know why, that's just like an accepted thing, right? It just doesn't make sense. The distance between 2 points is always the shortest distance. And the shortest distance is always the perpendicular distance. So when we say that it is equidistant to the sides, I may have to move my point to make my little red thingies fit. We're talking about the perpendicular distance to the sides. Because like I said earlier, all we know is that angle ABC is bisected. We don't know that the distance from AB is the same as the distance to BC.
Is it?
We don't know. No, it's not actually, I don't think. Okay? I don't know why I did. Okay. Now what have I created there? Focus on the two triangles. Two right triangles, where this acute angle is equal to this acute angle,
Oh, so now we have like sides.
Two equal.
and this is congruent to itself through the reflexive property.
Angle side.
So through the angle side postulate, I have two congruent triangles. Okay?
Corresponding parts.
Which is how all of this ties in together. It's giving us more ways to get to the fact that triangles are congruent. Okay? Oh, that's it.
Oh, yeah. Hey, finish.
All right. Turn to page. Don't pack up. Turn to page.
I'm like excited. Oh,
156. Tonight you are going to be doing 2 through 18, the evens. And numbers 2, 4, and 6, you're going to actually have to do some cutting and some drawing. So you're going to need a ruler and some scissors.
We need a ruler?
You're going to need a ruler because you got to be specific.
I mean,
Okay, we're not
scissors?
doing that right now. Yeah, number 6, they want you to cut something out. And do some folding and see what happens.
So how do we show that on
Okay.
the paper? We like stick it on the paper?
Yeah, you can just staple it to the back of the paper. Okay?
And then we fade along.
All right, so let's start with number 7. In number 7, we're looking at the picture of triangle SKN. I'm going to do my best to make it look like the picture, but it probably looks absolutely nothing like it because I already
Does anyone
forgot.
have a switch right there not using?
It looks like
I like it for you.
That's good.
Do my picture too pretty. Huh. Okay. Okay. Number 7 says if point X is on the bisector of angle SKN. So point X lies on the bisector of angle SKN. According to the theorems we just learned, which two sides of that angle is point X equidistant to? SK and NK. And if I was going to actually draw those little segments, what would they have to be?
How do you know
Right
which,
angles.
How do you know which one's the vertex?
Because it said X lies on the bisector of angle SKN,
Oh, so
and the vertex is in the middle. All right. So if that is the case, then X is equidistant from, so this length here is congruent to this length here, which doesn't look like it in my picture because that's freehand. Sorry about that. Which means basically that this triangle is congruent to this one.
So then S and K and K and N will be equal. Is that what they're trying?
No.
Yeah. Wait.
Not necessarily. Nope. If X is on the bisector of an angle, all we know is that that point is equidistant to the sides of the angle. We don't know that the sides of the angle are equal to each other. We just know
Equidistant.
that the distance here is the same as the distance here.
Okay.
So I have two congruent triangles right there. All right? Now, wasn't that cool? Okay. Number 9 says if, okay, this changes it. If X is equidistant, oops, wrong color. If X is equidistant from SK and SN, okay, which once again the picture is not very good. Then what must X lie on?
The bisector S.
Perpendicular.
The bisector of angle S.
Yeah.
The bisector of angle S.
So we show that by.
So what that means is that when I draw the bisector, I know that it's bisecting the angle. I know that the perpendicular distance was the same. So I have two congruent triangles through the angle, side postulate.